In this video, we are going to think of how we can view what volume is, what pressure is, what number of particles, and what temperature is from the context of the kinetic molecular theory. So the easiest way to explain here is obviously this number of particles, because it's just the number of particles that you have inside a container. So I have here an animation, and this animation is built to understand gas particles. If I can pump in some gas particles inside, notice that these are the number of particles, right? So this is an enclosed container. So how many number of particles you have there, so in this case you have 96, so there's a counter here. You have 96 particles. That's the number of particles. But again, in reality, we don't count the number of particles in terms of individual number, but in terms of moles. So you say there are 2 moles or 3 moles. So when I say there is 1 mole of oxygen gas molecules inside the container, that really means there is 602 sextillion 200 quintillion particles inside, because remember, molecules are very, very small. But in this case, this is a simplified animation, so we can count them individually. So notice, if I pump more, so obviously it doesn't take a genius. If I pump more particles, the number of particles would change. So in our context, the number of moles that we can have kind of changes also. So the number of moles that we have changes from 1 mole to 2 moles or so on. So that's how simple the number of particles is, or n. So the next simple thing to explain here is the volume, right? So the volume is simply the kind of the amount of space that is occupied by the gas. So if we can go back to our animation here, if you notice here, this is the amount of space that the particles can move in, can occupy. If we increase the volume like that, the gas simply occupies the additional space. So therefore, if this is the space inside the container, that's also the volume of the gas. If we kind of compress the volume into a small space, guess what? All the gas particles will be occupying the same space. So therefore, volume is simple in the sense that it's really just the space inside the container. If the space inside the container is 2 liters, the volume of the gas is 2 liters. If the space inside the container is 10 liters, because maybe you increased it, the volume of the gas is also 10 liters. So it's as simple as that. Now, the next one that we would try to explain is the temperature. So the temperature class is related. Okay, it's not completely equal, but it's related to the average kinetic energy of the particles. Okay, what does it mean, average kinetic energy of the particles, sir? Well, it's, you look at the particles here. If you look at the particles there, you can kind of know what is the kinetic energy of that particle, what's the kinetic energy of this particle, and then you kind of tally all of them, and then you take the average. Obviously here there are particles that are moving faster, there are particles that are moving slower, but if you can take the average, that gives you an idea of the temperature. So basically, if the temperature is lower, that means the particles inside are moving slower. Okay, if the temperature is high, that means the particles inside it are moving faster. Okay, so to show that concept to you, let us look at this animation. So if you notice, this is the behavior of the particles at this particular temperature, which is about 300 Kelvin. But notice what happens if I heat this up. So I want you to focus your attention onto these particles here. If I heat this up, notice what happens to the particles. See, they will be moving faster. But if I cool it down, see, I'm now cooling it down. Notice that the particles become slow in motion. Right? See? Look at that. The particles are now moving slower because the temperature has plunged to 75 degrees Kelvin. 75 Kelvin, no degrees for Kelvin day. 75 not 75, 79 Kelvin. If I increase the temperature by heating it up, now the temperature rises, and you see the particles inside are also moving faster. Okay? So that's the idea there. The idea is the temperature is related to the average kinetic energy. Kinetic energy meaning movement. So therefore, higher temperature means the particles are moving faster. Lower temperature means the particles are moving slower. Okay? So that's how we think of temperature. Now we can think of pressure. Now again, as I explained to you last time, pressure is force over area. Okay? So it's the amount of force divided by the area. So for example, if you have 10 newtons of force and the area you apply it is 1 meter squared, so you will get 10, and the Newton per meter squared is Pascal. So this is how we get Pascal, 10 pascals. Now in the context of the gases, we can think of it as this. See these particles? These particles are pushing on each other. See, they're colliding on each other, and they are hitting on the walls of the container. So when a particle hits the wall of a container, obviously it exerts force onto the container. Okay? So all of these particles that are moving, that are colliding inside the walls of the container, are exerting force on the container. And then all you have to do now is kind of count how much force is exerted on the container's walls, and then you can divide it. You can divide that force with the area of the container, okay, area of the walls of the container, and you get the pressure. Okay, so just a heads up, because this depends on force and area. So that means if you have particles that are moving faster, obviously as they hit the wall, they hit the wall more violently, so more force, so more pressure. If they're moving slower, when they hit the wall, the force is smaller, and therefore the pressure is also lower. But take note that it's an interplay between force. Take note that it's an interplay between force and area. So area also matters, because if the area is big, right? If the area is big, for example, if it is something like this, let me just illustrate that. If the area is big, so for example, if this is area 1, which is very small, if the particles hit the wall, bounces that on that wall, and then on that wall, and that wall, so it exerts some sort of force. But if the box is quite big, like this, if you have this particle, it hits here, it will take a longer time before it hits the other wall, because it's kind of farther, the walls are farther apart. So therefore, even if you have one particle here and one particle here, the pressure here is going to be small, because you have a bigger area compared to this one. So again, pressure is an interplay between force and area. So the area matters, the force matters, the movement of the particles also matters. But that's how we think about pressure. Okay, so another thing that I can also show you is that, for example, in this case, see, look at the pressure here. I hope you can see the pressure is reading right now 52 atm, right? If I add more particles, notice that the pressure kind of increases, because you have now more particles. So if you have more particles inside, more particles will be hitting on the walls, right? And so more force, and the area, you did not really change the area, so the pressure becomes more. If I release, so look at the pressure now is 90 atm. If I release some of that air, some of that gas particles, right, I let them escape. So I am decreasing the number of particles inside. Now the pressure is now just 42, because again, because some of it escaped, only a few particles are inside, and meaning only few particles are hitting the walls. Okay, so again, the concept of this pressure is kind of more complicated, because you have to think about how many particles are hitting the walls. You have to think about how fast the particles are hitting the walls. You have to think about how farther the walls are. Is the area of the walls bigger or smaller? But all in all of those factors are considered in thinking about pressure. Okay, So that's how we view volume, pressure, number of particles, and temperature in the context of kinetic molecular theory. Because remember, think about it. The number of particles depends on how many molecules there are. The temperature really depends on how fast, how kinetic the particles are inside. The volume is about how they spread out because they are moving they are kinetic, so they spread out into the volume. And pressure is about, again, the interplay between how much force those particles hit, how much force those particles exert on the wall, and how big the area of the wall is. So therefore, all of these four, volume, pressure, number of particles, and temperature, can be explained from the context of the kinetic molecular theory.